Alright guys, so we are going to draw and create the toolpaths and generate G-code for the ADV0203M drawing. Start off with, let's look at the width of the part. 1.94 by 1.94 square. Okay. So in Fusion, I'm going to create a new sketch. I'm going to select my top plane. I'm going to draw a rectangle. We'll go 1.94. I'm going to hit tab. 1.94. So I now have my main rectangle. Okay, so the base of this part is 0.516. Well, the overall height of the part is 0.516 tall, or thick, however you want to look at it. We're gonna run this on the mill, so sitting in the mill vise, it'd be 0.516 tall. And the base of this part is 0.366. So I'm gonna go ahead and extrude this up 0.366. So I have this now. This is my base. Alright, so now we have a circle, or like a hub, that's in the, looks like it's in the middle of the part. We don't know if it's in the middle. Looking at the map, it looks like it's in the middle, but the information we have that's exact is it's 0.97 from the side and 0.97 tall. And this hub would be 3/4 inch diameter. So I'm going to create a sketch. I'm going to draw a circle, and I'm going to dimension it from the bottom edge. It'll be 0.97, and from the horizontal edge 0.97. Alright, so the overall height is 0.516. Yeah, 0.516. And our base is 0.366. Now, we don't know this height. Now, we could calculate that, or we can just enter the math in the dialog box. So, I'm going to extrude this up. I'm going to go 0.566 minus, and this is where I can just enter, let's see, 516. I can enter 0.366. Alright, so it's 0.516 minus 0.366. And I like to turn this, reorientate it into like a isometric view to eyeball it, make sure it looks right visually. Looks good. Double check our dimensions. 516, 366, good. Okay, so it has a 1/4 UNC threaded hole all the way through. Now, I have this 0.201 diameter. That's the pre-drill size, so we're going to ignore that for now. What I'm going to pay attention to is 1/4 UNC. So I'm going to create a sketch. I'm going to hit C for circle and reference off the middle of that hub. And I'm going to type in 0.25. I'm going to hit E for extrude. I'm going to extrude this down. Now I accidentally selected the wrong face, so I can click these. Alright, so because I'm recording this video, Fusion's a little slow right now. I'm just going to hit X right here to deselect them and reselect that center hole. And I'm going to just pull this through. And I'll go to create thread. I'm going to select on this face. And I'm going to use a modeled thread. Thread type is going to be UNC. There we go. I'm going to hit OK. I now have that thread there. Go ahead and hit save. And I'm going to save this as Advance 203 M. Alright. So looking at this part, if you were to actually make this, you have to think, what kind of stock would you use? We're going to make this out of 2" by 2" stock that's 1 inch tall. So I'm going to go to manufacture, go ahead and close this window up, and I'm going to go to setup. I'm going to select the orientation, so orientation, I'll do select Z and X plane. I'm going to click on the face of this part to define my Z. My X is fine right there. I'm going to go to my stock tab. I'm going to put it on a fixed box. And it's going to be 2" by 2" by 1", except for I'm not going to have the model in the middle of the stock. I'm going to have, let's see, the model Z is going to be based off offset from Z plot positive. And I'm going to clear out this offset. Now, I want something to face off. Alright, so I'm going to offset it up 50 thousandths. And all this stock down here, that's what we'll hold on to in the vise as we walk around and cut out the main shape of the part. Alright, so now I'm going to move my origin to a more useful spot. I'm going to put stock point, and I'm going to select up here in this corner. Hit OK. So it's going to look something like this. I'm going to go ahead and rename this setup op 1. Okay, so I'm going to start off by facing the part. So I'm going to go to face, and I'll go to tool. Alright, so for this part, I'm just going to save this to the document. I'm going to add a tool. I'm going to go to face mill. I'm going to say it's a 3" face mill. I'm going to go to the cutter tab. Diameter is going to be 3 inches. I'll let everything else just auto update. The main thing is to get that diameter right. Cutting data. I'll go 2500 RPM on spindle speed and ramp spindle speed. Cutting feed rate, I'll go 20 inches a minute. Plunge feed rate, 25. Now you shouldn't be cutting anything on the plunge. Post processor, yeah, tool 1's fine. I'm going to hit select. Geometry, I'm not going to select anything. I'm going to let it pre-select the stock profile or contour. Height. Alright, so I'm going to change these clearance heights to 0.1. But the bottom height is going to be the model top. So Alright, so let's throw a fuss about the retract height. Instead of stock top, we'll put it top height. Actually, let's put it on feet height. There we go. Here, that's probably what it was. I'm gonna turn to the side view, make sure that's actually gonna be facing down to the top of the part. And let's hit OK. This is the toolpath it gave us. I'm going to simulate it. Looks good. If you wanted to, you could take it in 2 passes. I like to rename these toolpaths. You just click on it and type in what you want it to be. If you want to add a second pass, I'm going to go to multiple depths, type in 25 thousandths, and because I'm taking 50 thousandths off the top, that's going to have 2 passes. We'll simulate it. Alright, so let's rewind it a little bit. Right here, let's make sure it's coming off the part. So it's going back. It doesn't, man, it's cutting it close right there. It goes to the very edge and it comes down. We may want the tool to go to the left a little bit more. So when it comes down and plunges down, it's not actually touching anything. So let's make this we'll add 100 thousandths. Alright, so right here, alright, that didn't do anything. Instead of pass extension, let's put it on stock offset. Alright. So now if you look, it's coming off the part completely, then going down and feeding in. Looks good. Go ahead and hit save. Alright, so I'm going to go 2D pocket now. And I'm going to use a 3/4 inch end mill. So I'm going to select the document. Unless you already have the tool made, just select the tool that's already pre-made. I'm just going to make one just for the sake of this tutorial. So I'm going to add a flat end mill. It's going to be a 3/4 inch end mill. Cutter diameter, we'll make it 0.75. Oops. The only thing I changed is just the diameter. RPM, go 3,500 on the ramp also. 20 inches per minute for feed. 20-inch feed on the ramp. Plunge, 25. Tool number 2. I'm going to hit accept. I'm going to hit select. I'm going to verify my speeds and feeds the way I want it. Pocket selection. Let's select that and see what happens. Alright, height tab. My clearance heights, I'm going to change to 0.1. Top height, we'll put it on model top. Bottom height, I'm going to put it on selection. And I'm going to zoom in, I'm going to select this floor right here. I'm going to turn it in a side view so I can verify it's the right height. Looks good. Passes, I'm not going to leave any stock. Multiple depths, yeah, we'll do, we won't do multiple depths. Let's hit OK. This is the toolpath it gives us. Now we want to, the distance from this face to this face is 0.15. So let's go ahead and, if you want to add more passes, you can put it on multiple depths. It says, hold on, it was 0.15. Yeah, so we divide that by 2. We could take 2 passes at 0.075. It'll look something like this. Looks good. I'm gonna name this name it Circular Island. Okay, so now I'm gonna walk around the part. Since I don't have too much material cut off here, I'm just going to use a basic 2D contour. I'm going to select this chain as my driving geometry. And still using the 3/4 end mill. Now, my feed height, I'm going to put it on selection. And I'm going to select this edge because we already cut that. There's no sense in wasting any time. We just drop down and kind of ignore any unwanted passes. Top height, I'm going to put it on selection. I'm going to select this edge here as well. So it's going to be where that blue line is right there. And bottom height, I'm going to put model bottom. We'll go a little bit deeper. So it's going to look like this. Not too bad. Alright, I'm going to hit save. I'm going to name this toolpath outside contour. And if I wanted to actually outside contour or square contour. There we go, outside square contour. Alright, so now we have to drill and tap this. I would suggest center drilling it. You don't really have to, but now because I'm just using the center drill as like a little pilot hole, I'm not going to really worry about my depth of my center drill. I just want to put like a little dimple in there to help keep the drill cutting straight. Diameter, say it's a 1/4 inch diameter center drill. Cutting feed, yeah, we'll go 1500. Cut at 4 inches a minute. Plunge feed, yep, 4 inches a minute. I'm gonna hit accept. Select it. Verify the speed and the feed's right. Geometry, I'm going to select this face right here. So there's a little flat on the thread, right? where the thread is, there's always like a little flat. May not be much, but there's some kind of little flat right there. So I like to select that flat. Height. I like changing each of these retracts. Feed height for 100 thousandths. And change it to 100 thousandths. And the depth, I'm gonna put it on absolute and just tell it to go minus 0.03 deep. We're just gonna put a little dimple in there. So I turn my part sideways. Okay, so check this out. Now, when I did my stock, my Z0 is actually on the stock. We faced that off. So I goofed up on the center drill depth. On the bottom height, just put it from the whole top and then go down 30 thousandths. And you can see the little dimple right there. It's a little pilot hole. I'm gonna hit save. We'll name this center drill. Okay, so it's a 1/4 and we're gonna drill it for 0.201 to pre-drill it before we tap it. So what I'm gonna do, I'm gonna just duplicate the center drill, and I'm gonna click on it and rename it 201 drill. I'm gonna go to edit, go to the tool, and I'm gonna click on the document and add a drill. So my drill, I'm gonna name it 0.201 drill. Cutter, I'm gonna change the diameter to 0.201. Cutting data, we'll go 1500 RPM. Cut it 4 inches a minute. Tool number 4 sounds good. So I'm going to select that. And I'm going to change the cutting depth. It's going to be on, we'll put it on a whole bottom for the bottom height. If I put it on a front view, you can see the tip goes through. I'm going to select this drill tip through bottom, and I'm going to keep that minus 0.03 inch offset, because I like to have it drilled deeper than it needs to go. You know what? Actually, let's change that. Let's do the stock bottom. All right. The reason why is because we need to be thinking about our stock. Now, if your drill isn't that long, you know, you'd measure the cutting length and see what the maximum depth you can get for that drill is. If it's 3/4 inch and you drill that deep. I'm saying my drill's long enough to get it. So I'm gonna drill all the way through. If you can, it's good to drill all the way through. Even if you're gonna face off on the other side. The reason why is you get to flood it with the hole with coolant and evacuate any shavings or debris that's in there. So when you tap it, you don't have any shavings build up and possibly break your tap. Alright, so now I'm going to create the tap. I'm going to select, I'm going to click on my document, and I'm going to create a tap right hand. I'm going to name this a 1/4 tap. My cutter, we'll say my diameter is 1/4 inch or 0.25. I'm going to just hit tab on the keyboard and it auto updates this stuff. Now the thread pitch, we need to tell the software what the thread pitch is, so it will put the feed rate accordingly. because you're pretty much going to screw this tap into that pre-drilled hole, and it's going to cut out the threads, right? Now, because of that, it has to be moving. It has to be feeding in per revolution, whatever the pitch is. So whatever the distance from thread to thread, whatever that distance is, that's what the feed rate needs to be based off of, right? So it's a 1/4 thread. So 1/4 inch distinguishes the major diameter of the thread, and 20 distinguishes the number of threads per an inch. Okay. Now, if we want to find the distance between thread to thread, what we have to do is take 1 inch and divide it by 20, and that will give us the distance from thread to thread, which should be our thread pitch here. So with the calculator, I'm going to go 1 inch divided by 20 threads, which is 0.05. So I'm going to change this thread pitch to 0.05. Cutting data, I'm going to go 450 RPM. Notice there was no feed rate. That's because the feed rate is fixed. Whatever the RPM is going to calculate the needed feed rate to drive that tap, where it's 50 thousandths per thread. So, the tap will make one full revolution and advance 50 thousandths deep as it goes. Tool number 5 is good. Hit select. Geometry. I'm going to click zoom in and click the little flat face of the tap. Height. We'll change each one of these to 100 thousandths, except for the top height. The bottom height, we'll do whole bottom, plus we'll go deeper. Go an extra, extra 200 thousandths deep. It really depends on what kind of thread or what kind of tap you're using. If you're using a plug tap or a tapered tap, you might need to go deeper or not as deep. This looks like a good depth here. I'm gonna click on my cycle type. Now notice it already says tapping. That's because I created threads. I'm using a tap, so the software is smart and realizes that I'm tapping. Okay. Looks good. All right. So that's the first op right there. This is what it looks like. Alright, I'm going to name this 1/4 tap. Hit save again. So that's my first op. So now all we got to do is get the part to height. Alright, so it's 0.516. Our stock was 1 inch thick, and we faced 50 thousandths off of it. So it was 1 inch stock. We faced off 50 thousandths, and the overall part height is 0.516. So we have roughly 434 thousandths to face off when we flip the part over. So the easiest thing to do is just duplicate this whole operation, or it makes a second one. select it. I don't need any of these other toolpaths. If I select the toolpath, the first toolpath I don't need, and hold my shift key down and go to the very bottom one, I could delete that whole stack. I only need the face. And what I'm going to do is I'm going to edit this setup, and we'll change our z-axis to right here. So we had 434 thousandths to face off of it. So I'm going to offset this 0.434. Or if I wanted to, I could actually do my height Z from offset from bottom. Yeah, offset from bottom, Z minus. Now the stock is only 0.95 now. So you can use a calculator and enter this, accordingly, or you can just update the stock parameters there. Looks good. You could change it by preference if you wanted to. You could actually, you could put the X and Y on that corner of the part. Just for the sake of simplifying this tutorial, I'm going to leave it on the stock corner right there. Now, you're actually making this part. You may or may not. It's kind of preference. But you could, because we're just facing it. Okay, instead of stock box point, you could do model box. Now, if you did it like this, you would have to reset. I would reset the Y0 based off of the jaw. Now, it's gonna be kind of hard to do that because you have this massive stock left to face off, and when you put the part in, the edge finder would hit the stock before it hit the part. So the only way to really do that correctly is to take the stock out of the device and actually use the edge finder and bump up against the fixed jaw to get the Y0, and then put the stock in. Alright, so it's kind of preference. If you're an experienced machinist, you probably want to do it this way. If you're new to Fusion, you might want to keep things simple and just have your X and Y0 based off of the stock box point. It's preference, whatever you want to do. But there's two common ways of doing it. Just keep in mind. And that's only on the second up. Alright? That's because when you're holding on to the part, your part, this face of the part, not the stock, because we done removed a good portion of stock. And we could update that in Fusion, but that requires a lot more work. Typically on something like this in Fusion, you just go off what the largest point on the stock is. You would have to draw up a model of what the stock currently looks like. And typically, like doing something like this, you'd probably leave these parameters the same. That's what's commonly done. Alright, so I'm going to hit OK. And I'm going to go to this face. Now, because that was a duplicate of the first operation, I'm going to have to go to Edit and reselect this stock. Well, I didn't reselect it. It automatically did it for me as soon as I clicked on geometry. Bottom height is going to be the model top. And I think we're good. Let's hit OK. This is the toolpath it gives us. And it looks something like this. We'll speed this up some. Alright, that's your face operation. Now I'd finish the part to the correct height. And that's pretty much it on this. So you got two operations. You know, you can select this first op, generate, you know, post process it, generate the G code based off the machine you want to use, and then you would generate G code for the second op. And we'll go ahead and rename this. We'll make it op 2. But that's pretty much it. Let me know if you have any questions.